All right, let's talk about 11.3, arcs and central angles. So there's a few vocab words we're going to need for this section. So the first vocab word we're going to talk, or vocab words we're going to talk about is minor arc and major arc. So 2 points lying on a circle actually define 2 arcs. The shorter arc is called a minor arc, and the larger arc is called the major arc. So to the left here, I have a circle. It's circle, that dot in the middle, of course, is that center. Again, it says 2 points lying on a circle. So I'm going to make my 2 points. My 2 green points. All right, I'm going to connect them with some radii, which we know what that is. Okay, so I have my 2 arcs. I'm sorry, my 2 points on the circle. The shorter arc, and an arc is like a curved shape. It's not a straight line, so it's not my radii. My minor arc is the shorter arc. So in this case, my minor arc is this green part. And then my major arc is going to be the other half of that circle that is not colored. So in this case, my green is my minor, my blue is my major. These are arcs. Okay, let's talk about how to find the measure of a minor arc. So the measure of a minor arc is the measure of its central angle. Well, in a circle, angles add up to 360. So that entire green little circle adds up to 360. My central angle always goes from the center of the circle and then opens up. So in this case, this part is called my central angle, this green little part that I just drew in. My central angle, in this case, this angle here, is the same measure of my arc length, so that green part, which means, now we don't typically do this, but this blue part would be the measure of the blue arc. So then to find the major arc, the measure of a major arc is the difference of 360 and the minor. So if I have my minor arc, let's call this, let's say 50 degrees. The measure of my major in the blue, again, a circle adds to be 360. So the measure of my major is just 360 minus my minor, which is 50. So the blue arc measure is 310. Okay, so my minor arc, or the green part, is just the measure of the central angle. And then my major arc is just 360 minus the minor, or the smaller part. Okay? Erase all this stuff. All right, let's talk about a semicircle. Well, we know what semi is, and we know what a circle is, right? A semicircle is half of a circle. Okay? An arc whose central angle measures 180 degrees. A semicircle is formed by 3 points. And then congruent circles. Well, we kind of figured what this was. 2 circles are congruent if they have the same radius. Okay, so if I have 2 circles and their radius was, let's say, 2 meters, both of them are 2 meters, then those 2 circles would be congruent. Okay, and then congruent arcs. Congruent arcs are 2 arcs. I'm sorry. 2 arcs are congruent if they have the same measure. So if, let's say, my green arc was 50, in this case in my picture, and I have another arc that's 50, those 2 arcs would be congruent. And my last one, the arc length, which this one we're going to talk about a little bit later, but we're going to go over the definition right now. So it's an arc length is a portion of the circumference, that should be a T there, the circumference of a circle. Again, we're going to talk about that in a bit. Let's move down to example 1. So name the gray arc, or in this case I labeled it with purple, and identify the type of arc. Find its measure. Okay, so in A, it's either a major or a minor arc. In this case, in A, the purple part is the smaller part. So in this case, it's going to be a minor arc. So my minor arc is DF. And the way we measure an arc is with that little curved line on top. When we when we label segments, lines, we have a line on top. For arcs, we have a curved line. Okay. So DF is a minor arc. Its measure is going to be the same as the central angle. In this case, my central angle is this angle here, which is actually 40. So DF is 40 degrees. All right, B, let's look at the second picture. So again, I'm looking at the purple highlighted part in this case. So arc LMN is is it a major or a minor? Well, if it's a major, it's the bigger part. If it's a minor, it's going to be the smaller part. In this case, this purple part that is highlighted is actually the bigger part. So this is the major arc. So LMN is a major arc. Its measure is 360 minus the minor arc. In this case, my minor arc is 110. Well, 360 minus 110 is 250. So the measure of LMN, which is the major arc, is 250 degrees. Well, let's talk about postulate 16. Arc addition postulate, similar to angle addition postulate, segment addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. Okay, so in this case, I have a picture to the right. I colored mine in. I have two different arcs that I'm looking at. So if I wanted to find the big arc of ACB, I'm going to find the measure of the arc AC plus the measure of the arc BC. I will get that big portion. Let's talk about example 2. So I want to find the measure of the arc GEF. Okay, well, by the arc addition postulate, I can add 3 different arcs together to get GEF. So let's do the measure of GH. That's that one. Well, in this case, I see that that one is actually 40 degrees. So I can put that down there. Plus the measure of HE, which is this one here. In this case, we see that that one is actually 80 degrees. And then lastly, the measure of EF. And that one we see is 110. 110 degrees. Well, to get the measure of all those 3 added together, or the arc GEF, add those numbers up, and I should get 230 as the measure of GEF. Let's go down to example 3. Find the measure of the gray arcs. Again, in this case, I labeled them in purple. It's a little bit better to see in purple. Are the arcs congruent? So let's talk about A. Notice that arc AB and DC are in the same circle. Because the measure of AB is equal to the measure of DC, which is 45, we know that AB, arc AB, is going to be congruent to DC. They are congruent because they have the same measure and they're in the same circle. Okay, so that's 2 things we need. Same measure and same circle. Okay, notice, for B, notice that X, Y, and ZW are not in the same circle or in congruent circles. Okay, again, congruent circles are, they have the same radius. In this case, they do not have the same radius. I have a small and a big one. So, therefore, although the measure of XY is equal to the measure of ZW, which is 65, because they are not in the same circle or congruent circles, XY is actually not congruent to ZW. Again, we do need those two things. They have to have the same arc measure, and they have to be in the same circle or congruent circles. Let's go down to arc length corollary. So in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360. So we're going to put these words into a smaller formula. So the arc length, again, arc length and arc measure are different. Arc measure is going to be in degrees. Arc length is going to be in inches, meters, units, whatever you have. So the arc length of AB is actually going to be this formula. The measure of AB, arc AB, over 360 times 2 pi r. 2 pi r is the the formula for a circumference of a circle. Okay, so this is the ratio of the measure of the arc to 360. That's that circled part that I just did. And then this part is going to be just that circumference part. Again, this is the formula we're going to use for length. Again, length is different from measure. Let's go down to example 4. So find the length of the gray arc. Round your answer to the nearest hundredths. Hundredths is 2 decimal places. I'm going to color these in. We're looking for this arc, and this arc. So instead of gray, we're going to do purple. All right. So for A, find the length of arc AB. Again, length is inches, centimeters, meters, units, whatever you have. So I need to use that formula that we just learned above. So I have something over 360. Well, that something over 360, the something is going to be that arc measure. Well, in this case, in A, my arc measure is 50 because that angle, central angle, is 50. So I have 50 divided by 360 times 2 pi, in this case, r. My r is my radius, and if I look at A, my radius is 5. In your calculator, do 50 divided by 360, whatever number you get, times that by 2 pi 5. So 2 times pi times 5. There is a pi button in your calculator, or you can use the calculator on Desmos. When you plug this into your calculator, solve it, you should get 4.36 centimeters. Again, in this case, my units are based on the units that I'm given in A. So I am given centimeters. Let's find the length of arc CD for B. Again, it's something over 360. That something is that angle measure, or that central angle of that arc. In this case, that central angle is 50. And then it's 2 pi my radius. My radius is 7 in B. Again, plug this into your calculator. Do 50 divided by 360 times 2 pi 7. Again, pi is a button in your calculator. You might have to press second, depending on the calculator. When you plug this into your calculator, you should get 6.11 centimeters. 6.11 centimeters. Lastly, let's talk about C. So find the length, the arc length of EF. So EF, again, is that purple part that I highlighted earlier. Again, it's something over 360. That something, again, is that arc measure, and I'm pretty sure you guessed it already. That arc measure is 98. So 98 divided by 360 times 2 pi, in this case my r is 7. When I plug this all in my calculator, I should get 11.97 centimeters. Now at this point, the next 3 problems, the checkpoint down here, I'm going to say pause the video, try it on your own, see what you get, and then play it. Hopefully you tried them by now. I am going to go over them as well. So again, I want to find the length. We're using that formula that we learned for the arc length corollary. So it's something over 360 times 2 pi and my radius. So if I talk about 5, that something is going to be 120 because that's the length of my purple arc. So 120 divided by 360 times 2 pi. In this case, my r is 2. So I have 120 divided by 360 times 2 pi 2. If I plug this into my calculator, I should get about 4.19 inches. Okay, again, my units follow what I'm given. I'm given inches, so I have to end with inches as well. All right, let's set up number 6. So I have something over 360 times 2 pi r, which is my radius. All right, that something again is 180. The top part is 180. Well, if an entire circle is 360, and I'm given the top part is 180, subtract that from 360, and I actually get this bottom part down here to be 180 as well. So this is 180. Times 2 pi r. My r in this case is 4. Okay, so 180 divided by 360 times 2 pi 4. Plug it in, I should get 12.57 feet. And then lastly, number 7. Again, hopefully by now we're able to do some of these on our own. So I have 360 on the bottom. 2 pi, what's my r? My r is 6. My angle or central angle is 90. So I have 90 divided by 360 times 2 pi 6. Plug that into my calculator. I should get about 9.42 centimeters. 9.42 centimeters.